powers. Let's move on. Law 4 of the indices. Okay, first law, addition. Second law, subtraction. Third law, the zero law. Then this law is called the power law. Okay, the power law. All right. You know, we attach name to this law so that you can get familiar with any question you see. All right, power law. What's power law saying? Power law is in three forms. All right, the first part is when you have a raised to the power of m and n. You should have seen this before. Okay, or if you let's see it. This a raised to the power of m, raised to the power of n, where you have power of a power. All right, what do you do? Okay, a raised to the power of m, then mark them by brackets, and m multiplied by n, you multiply the powers. That's mn. What is this saying? When a power is raised to another power, what you just do is to multiply those powers to get this. Okay, the second aspect of this law is when you have a raised to the power of ab, beg your pardon, ab raised to the power of n. All right, now I want to ask you a question. This power belongs to which identity, a or b? Definitely both of them have the share. Okay, because of this bracket sign. Bracket sign has embedded, all right, and each of them has their share. So what we do, can allot it by saying a raised to the power of n and b raised to the power of n. All right, a raised to the power of n, b raised to the power of n. What about the third category of this law? All right, in the third form of this law, you will learn that a raised to the power of b, a over b raised to the power of n, will also give you, since both of them are embedded in the bracket, whatever power the bracket has belongs to each of the identity. So we have a raised to the power of n over b raised to the power of n. As simple, okay? Technically simple, all right? Power belongs to everything in the bracket, okay? So let's see, as usual, our revision, okay? Examples, questions, okay? All right, let's have our first question here. Let's say you could be given a raised to the power of 3, raised to the power of 2, all right? You know, to do justice to that, you could also be given 3x 4, all right, and a power of 3. Or a third question of say minus 4a, all right. What other aspect? It could be b c cubed raised to the power of 4, all right. Don't be afraid, all right. We get to the root. Okay, you could also be given, say, minus 4 a, okay, probably close the brackets, square 3, all right, just to simplify. Most of these things, what we do is to simplify. What will they result to? Okay, or lastly, let's give another example. 25 could have 25. Sorry, that's our meter rule. Okay, right, let's move on. Okay, could have 25x raised to the power of 6 in half. Okay, so let's do justice to these 5 questions. Solutions. All right. So first one, you have 8 raised to the power of 3 raised to the power of 2. Here, what do you do? Simply put 8 raised to the power of 3, okay, 2. Then mark it to the bracket. Can you see? All right. That gives us, then multiply the powers, m times n, mn, 8 times 3 times 2. All right, that's what? 6. So 8 raised to the power of 6. That's the nitty-gritty about power law. Alright, the second one 3x power 4 all in brackets power 3. Alright, I told you the other time 3 is for each and every identity in this bracket. That is, every one of them has their parts. So here we have 3 raised to the power of 3 bracket x raised to the power of 4. What have I done? The same law that I applied here. Okay, apportion the power to each number in the bracket or each identity. Okay, so here 3 takes this, x raised to the power of 4 takes this. 3 raised to the power of 3 gives us what? 3 multiplied by 3 multiplied by 3, and that's 27. 27. Okay, 27 x raised to the power of 4. The same law applies here. 4 multiplied by 3, that's 12. No more, no less. Did you get that? Yes. Let's move on to 3 minus 4a into bracket b c raised to the power of 3 raised to the power of 4. Alright, look at this. A bit cumbersome, no issue. This minus 4a, okay, remember this 4 is for each identity in the bracket, and that gives us b raised to the power of 4, okay, c raised to the power of 3, okay, multiplied by 4. Okay, that's 4a minus 4a, b raised to the power of 4, 3 times 4, that's 12, c raised to the power of 12. As simple as that. That power does not affect the number outside, but the number within the bracket, within the confine of the bracket. Okay, then let's do the fourth one. The fourth question. Minus 4a raised to the power of 2 all into bracket 3. Oh, look at this. Related to this. What's the difference? This has all its values, all its identity embedded in the bracket, while this, they are separate. Okay, so once it is in the bracket, it means that each identity has a share of the power, and that's minus has its own share of power 4, 4 has its own share of power 4, and a raised to the power 2 has its own share of, power 3. Beg your pardon, power 3. Okay, power 3. A dot indicates multiplication. They are joined together. Okay, so minus in 3 places. Minus times minus times minus. Recall in our previous lessons that minus times minus is what? Gives us plus. So multiply by minus here. So plus times minus gives us what? We said good. Minus. Alright. So minus raised to the power of 3 is minus 4 raised to the power of 3. 4 multiplied by 4 multiplied by 4. That gives us 64. Okay? And here a, you don't multiply here, you just what you have business with the powers. Okay? 2 and 3, not a. Okay, just a. 2 multiplied by 3, that's 6. Did you get this? It's as simple as that. Then let's move to the fifth, which is the final question on this law. Alright, 25 raised to the power of x, okay, 6 and half. Okay, this is 25, x raised to the power of 6 and all power half. Okay, now look at this. What do we do? That power belongs to the identity in the bracket. 24 has no share in it. Okay, so that's, repeat, 25 rather. Then x raised to the power of 6 multiplied by half. Did you get that now? Alright, that's 25. When you multiply, let's take this outside. Okay, 6 multiplied by half. That's here 1, here 3. Alright, 3 times 1, that's 3. So we have x raised to the power of 3. That's a multiplication of the power. So 25x cubed. That gives us the end of the question here. So to revise this, I said power law. I told you 3 dimensions, a raised to the power of mn. Multiply the powers, you get this. here each of the numbers or identity in the bracket has its own share of the power, and that's n multiplied by this, n goes to this. The same thing for this, n goes to this and n goes to this. The same thing that is applied to these questions. All right, 3, 2, power of power, multiply, 3 multiplied by 2, that's 6. Never say 8 raised to the power of 32. No, it is not done. It is 8 raised to the power of 3 multiplied by 32. All right, never say it's 32, but this. Okay, then this, each of these are the share of this. All right, so 3 cube, x is to the power 4 cube. 3 times 4 gives you 12. All right, and 3 raised to the power of 3 gives you 27. Then this minus, you can see the question. This has no share in this. It has no share in this. So just take this, b raised to the power of 4, right? C cube raised to the power of 4. 3 times 4, 12. Then do, okay, then you solve further. Then the fourth question, everything in the bracket has a share in the power. So minus takes its own share, all right? 4 takes its own share, while this takes its own share, okay? These dots could be there and it could be exempted, all right? It just signifies that they are together. And minus 64a raised to the power of 6, that gives us the answer. Then the final question, 25, x raised to the power of 6, all into brackets, this. I told us that this half has no business with this. So come, bring this one down. Then here, 6 multiplied by half, the power law. And that's what we did here, 2 here, 1, 2 here, 3. And so 2 here, 1, 2 here, 3, that's 3. So x raised to the power of 3, that's 25. So that gives us the end of the power law, which is the fourth law of indices. I'm very satisfied that you understand this.